The assignment required student groups to each source an appropriate civil engineering case, and along with that, we had to critically evaluate the BOQ with respect to SANS 1200G document, which is the concrete section. Due to time constraints and confidentiality issues, it was very difficult for anti-halcos consultants to get hold of contract documents from civil engineering companies which were contacted. As a result, we decided to use case studies that had already been used and analyzed by pause groups. The case study chosen was the K2 wastewater treatment plant, and it was used by Candor quantity surveyors back in 2015. The case study itself involved, as previously mentioned, K2 wastewater treatment plant. It's located in Farm Bestwood Road 459 in K2, Northern Cape, Cape Town. The client was Gamagara local municipality, and the engineers was Worley Parsons engineers. The project was estimated to be about 18 million rand. The scope of the works included the construction of a biological reactor, a new RAS-WAS pump. The RAS is short for return activated sludge, while WAS is short for waste activated sludge. The scope of the work also included the construction of a supernatant pump station, a sludge drying bed, the renovation of existing chlorination building, interconnecting pipeworks, and general site works. For the purpose of this assignment, only the biological reactor's BOQ was chosen and analyzed.
Formwork according to the Worley-Parsons BOQ. Clause 5.2.1 states that formwork is to be classified in accordance with the surface condition required on the finished concrete. The schedule of formwork items measured in the Worley-Parsons BOQ for the biological reactor was separated according to the classification stated in the SANS 1200G document. The formwork items were measured in meters squared as required by the SANS 1200G document. It was categorized according to the class of the finish, rough, to the angle of inclination from the vertical, horizontal, sloping, and vertical, and ultimately into the various elements into which the formwork is required to support. The payment reference for rough formwork in the BOQ, given as clause 8.2.1, is in line with the SANS 1200G document. Smooth formwork items were measured in meters squared. The payment reference for smooth formwork is 8.2.2, which adheres to the SANS 1200G. The items were then further categorized according to the angle of inclination from the vertical, and finally into the various elements to which the formwork is required to support. The measurement and categorization of that item complies with the requirements of the SANS 1200G document. Boxing out of holes and forming voids were measured in number. Distinctions were made between circular and non-circular. The diameter in meter of circular items as well as the area in meters squared of non-circular items were stated. The division between small and large voids for both circular and non-circular items were correctly classified. Pockets for HD bolts were also given a number.
The reinforcement item was measured in tons, as required from the SANS 1200G document. The payment reference for reinforcement is 8.3 in the BOQ. This is in accordance with the SANS 1200 document, provided the reinforcement is a scheduled item. If this isn't the case, the payment reference should be 8.1.2 to be in accordance with the SANS 1200G document. The payment reference for the basic price of the high tensile and mild steel bars are 8.3.1. It is unclear whether the bill specified schedule reinforcement items. If it did, the BOQ is in accordance with the SANS document. If reinforcement isn't scheduled, the payment references for the basic prices should be 8.1.2.2 to be in accordance with the SANS 1200G document. There isn't a payment reference for extra over items. This isn't in accordance with the SANS 1200G document. The payment reference for the extra over items should be 8.9.2.3 for both high tensile steel bars and mild steel bars. The measurement of reinforcement complies with the requirements of the SANS 1200G document. If reinforcement is a scheduled item, if it isn't a scheduled item, the payment references of the BOQ need to be adjusted to be in accordance with the SANS 1200G requirements.
The thickness and grade of the concrete in the blinding have been stated, therefore the concrete has been measured in meters squared. The items have been separated based on the grade of the item and for the element of the structure in accordance to the clause 8.1.3.2. The proportions and elements have been stated as well. The items in clause 8.4.4, the items have been separated in accordance to their required finish as well as a special finish. The measurement of the concrete in the Worley Parsons BOQ complies with the standard requirements of the SANS 1200G document.
SANS 1200G explains the measurement and payment of joints in clause 8.5. The unit of measurements for joints is meters. The document states that separate items will be scheduled for construction and inspection joints of different types and sizes, qualities of water bars, soft boards, sealers, etc. Additionally, the rate of each unit shall cover the cost of all materials, labor, formwork, testing, and making good. According to the BOQ, the items measured were according to SANS 1200G documents as the items were measured in meters. Also, the items are separated according to different joint types as required which then adds up to 14 different joints.
The grouting item was measured in meter cube as required from the SANS 1200G document. The measurement of the grouting complies with the requirements of the SANS document, and hence it was done correctly. In conclusion, after the completion of this assignment, Eticalcus consultant had a better understanding of the SANS 1200G document, and it helped us into understanding what we need to do for the civil engineering simulated office project. We noticed the importance of payment reference and how essential it is in a BOQ, because even if the items are not measured in order, it is important that it's properly referenced. It was also noted that the SANS documents are only a guide to civil engineers, and they don't really have to abide by what's written there, as long as the correct references are used. Additionally, it was noticed that in comparison to the ESA/QS standard systems, the SANS document follows the mode of procedures of work that is measured on site. What I mean is that instead of having concrete formwork reinforcement, the order of measurement here is formwork reinforcement and concrete, which is correct according to the actual work that is carried out on site. Measuring in the order of how work is generally done is a great way to make sure that everything has been measured and nothing has been left out. Thank you so much for your attention. Goodbye.